Hi guys, let's solve today's Leetcode problem, which is problem number 796, rotate string. It's a easy problem. And what we are going to cover as part of this problem is brute force approach, optimal, that we will calculate manually. And then we will see how you can use C++ STL to solve this problem. Okay. So given two string S and goal, return true if and only if S can become goal. Okay. After some number of shifts. Okay. A shift on S consists of moving leftmost character of S to the rightmost position. Okay, for example, if S is like this, then it will be B C D E A after one shift. Okay, so you see this A is moved, that is the left character in this string has moved to the rightmost position. Okay, so this is one shift is nothing but same as rotation. Okay, but it is this one, like clockwise rotation, so that is same. In this one, if you see A B C D E, so here A is first moved to here, so it is now B C D E, then B is moved, so C D E A and then B. Okay, so here it was A. So after two rotation, we see that this is and this is same, right? So we are able to achieve this goal. So for that reason, this is true. And for this one, if you see after any rotation, we won't be able to achieve this. So this is the problem. And now let's start solving this. Okay, so what is the brute force approach for this problem? So it is nothing but whatever is being asked in the question, we will simply do that. And what is asked in the question, if you see, so we have to check if these two strings are same or not, even after shifting the characters. So how many times we can shift at most is n times. If we shift, then the string becomes the same as the initial one, right? So after n shifts, n is where the size of this string. If we find this both of the strings same, then that will be our and then it will be true, otherwise no, right? And one more thing is, so one thing is to check is, since here if you see the constraint is very low, this brute force approach will work. And one more thing, that here nowhere it's written that the string's length can be same. Okay, so therefore we need to have the check on string length. Okay, string length. So if string length, length of S is not equal to length of goal, then we can say that it's not achievable. Okay. Second is, we can see if the string and goal are initially itself, equal. So we don't need to do any check or anything. So we can say that, okay, if S is equal to goal initially, then which means it is already same. We don't need to anything, so we can return true. Otherwise, we need to do shifts. Okay, so we will start with doing one shift, and we will go till n shifts. Okay, that we will do in our question. um, n is basically n minus 1 shift only that we will do. And every time after shifting, we will see if the string matches or not. If it matches, then return true. Or otherwise, after doing all this operation, at the end, if it no one, after every rotation we checked it didn't match, so we can return false from here. Okay, so yeah, so this is what the brute force is. Now let's write code for this one. So it is nothing but code is, we will have this method, you know rotate string whatever, and it has this, I'll just write the pseudo code for this. Okay, so we will have this length, if int n is equal to, let's say, s dot size, and m is equal to goal dot size. Okay, now we will check if n is not equal to m, which means size is different, then we can directly return false. Okay, otherwise, and otherwise we need to check if they are equal. Okay, so f is s equal to length, then we don't need to do any rotation, so we can directly return true. Okay, now we can start this loop from 1. Why 1? Because 0 rotation we have already checked, so we need to check for 1 rotation. Okay, so this loop will go till 1 till n minus 1, and here we will check. So here we can call the rotate function, and this rotate function we can write on our own also. uh, which is nothing but, we have given this string, A, B, C. So if we have to do the rotation, so we will start our I pointer from here somewhere, and we will keep on moving, and we can have something like, temporary string, where our answer we will keep on storing, right? So we will store, in this example, if you see, we will store B, C, and after C, we see there is nothing, right? So here we will do mod also. Okay, so this indexes, if you see, 1 0 1 2 3. So for 3, if we do 3 mod 3, so it will be 0, right? So again we will come back to this. So yeah, so it will add C, and we will do this iteration n times, that is length of the stem, sorry, length of our S. So we will be able to rotate this these many times. Okay, so for each rotation, it's like this one, if we follow this approach, so we are starting this rotation every time, fresh. That is, let's say I have to start rotate 3 times or 4 times, so we will start from, let's say we have to rotate 2 times, so we will start from this index. So if we follow this approach, so here we are moving that many times the indexes, right? So which is nothing but, every time we need to move. So at max, roughly it will be, let's say for first time, when you have to do one rotation, then two rotation, then three rotation, and four rotation, and so on, right, up to size, that is n rotation. Altogether, when we sum this up, it is nothing but uh, n into n plus 1 by 2, plus or minus, you can check that. So yeah, so something like this, right, which is nothing but n square times, I mean, altogether it will take rotation, will take n square. I mean, all this approach. But rather, what we can do is we can store this temp variable here itself in this loop, and after that, what we can just do one rotation every time. So one rotation is nothing but copying this and then pasting it at the end. Okay. That is O of one operation. If you see, we can copy this string into something different variable. So it can be something like a string concatenation method we can use, or something like that. So yeah, but anyways, this is what we are going to do. I mean, here it will take O of n square time only. Okay, so now we will use the here also, we can call this rotate function, but C++ STL provides this rotate method, which basically we need to pass s dot begin as the begin of the string, and s dot end, sorry, s dot begin plus 1, and then s dot end. So what does this s dot begin, 1 represents? So this is nothing but doing one rotation at a time. This tells from beginning you do one rotation and till the end. Okay, so this is what the C++STL is for, and at the end we can check if s is equal to goal. Every time we will check if that is the case, then return true, otherwise at the end return false. Okay, so yeah, that is about this approach. And inside this loop also, like whatever I explained, right? So this rotate function also takes O of n time for doing this rotation. So that is why, and this loop is also running for O of n time. So time complexity for this approach is nothing but O of n square. Okay, and if we discuss the space complexity, so um, rotate method, it can take, this additional string, that temp that I shared, right? So yeah, it can either take O of n or O of 1. So yeah, this is time and space complexity for this approach. So that was about the brute force. Now let's discuss the optimal approach. Okay, so optimal is nothing but when we have given this string, let's say A, B, C, D, okay, E, and we have to form something like C, D, E, A, and B, right? Now what we can do is, we have given these two strings, right? So we will start the comparison from here one by one. Okay, so if we do one by one, after this we need to, either we can do either modulo to check back until n times, if that is the case, or one thing is like, Let's take this example. Okay, so there is two things that can be done. Okay, after breaking the string, so let's say I started with this a, and this another variable here c. So I see c and a doesn't match. So I, because this is a rotated string, right? So we can check for the next one. D also doesn't match, E also doesn't match. Here we got A matches. Okay, so now since A match with this A, we can say that it has started from here. So now we can move both the indexes. So here it is B and here also B. So this also matches. Now we'll move to next index. Now for this B, we know that there is no next index, so we have to move this to C. Okay, so here we see this C and this C also matches. Now we will move to next. So it is D. So this D and this D also matches. Now we will move to next. So this E and this E also matches. Okay. Now we reach till the end of this string S. So this was our S and this was our goal. Okay. And we see that at every point we were able to match it. Okay. At any point if we are not able to match it, then we can directly return false. Okay, so that is the approach is how does it, I mean, this is how it looks like normally. The key was here that if it is not matching, uh, I mean, if we have reached the end of this string goal at any point, then we can say that okay, do the modulo. So modulo will give us this index and then we will start the comparison. Okay, so yeah, this was about this approach. But there is one more thing that can be done, if we want to avoid this modulo operation. So it would be nothing but we can write it as a b c d e, then we can repeat this string one more time. Okay, so a b c d e. Now if we start the comparison, so we see that now what we were doing, we were matching s with goal, right? And if it was not matching, we were moving the index of goal. Okay, now, instead of doing that, what we can do is we will move the index of goal. We will match goal with S. Okay. So in this, we will move this index of S. Okay. This is what we will move. Now we will again start the comparison. So this is our new S and our goal is C, D, E, A, B. Okay. Now we will keep this C here and this A here. Now we will see these two doesn't match. We'll move next. B, D doesn't, sorry, this will remain here only until we match it to someone. Okay, so C and B also doesn't match. Then we see check this C and this C matches. Okay, now we will keep on checking. Okay, this D match, E is a match, A is a match, B is a match. Okay, now we came till the end of this string goal and we see that all of this matches with this. Okay, then we can return true. If it doesn't matches, then we can maybe try with the next possible thing, something till the length of this we can try, because there can be a match somewhere at the end, last index starting from here also, right? Basically n minus 2 or n minus 1 rotation might have done. So yeah, n minus 1 rotation might have done, so we can try that. And yeah, as I told, right, we did 1 to n minus 1 rotation, because 0 rotation will give me the same string s, n rotation will also give me the same string s, and we have already checked for 0, so we don't need to check for n rotation. Okay, so that is why we were doing from 1 to n minus 1. And one more thing, why this uh, duplicating this, taking this string twice works, because we know that after rotation, anything that is going to move is from this leftmost index, it is going to move right this side. So if you see A B C D E, A B C D E, now let's say if we move one rotation, so how would the it would be, A will go next here, right? So initially this was our length. Now we did move one rotation, you see this matches. This is how after one rotation it will look like. Now let's say we do two rotations. So first we moved this and then we moved A, B, B also after this. So here it is. Now after that we see this is what the string is, where two A and B has been moved, right? So similarly we will, after doing double this string concatenating this twice, we were able to achieve all possible rotations. So this is a simple rotation trick which is very useful in other cases also. Yeah, so I think this is very straightforward. I won't write code for this one. Now we can discuss the optimal one, that is using the C++ STL. Okay, so here the uh, I mean, here what we were doing, right? We were doubling the string, and every time we were finding it by moving this index one by one, right? And what can be the time complexity? In worst case, we would be able to, move to this s twice. Okay, so we started from here, we didn't match. Then for n minus 1, let's say there was a match, basically there was n minus 1 rotation, then we will be able to move, we already moved this half, then we have to move the remaining half. So at max, time complexity would be O of 2n. Okay, and space complexity, if you see, so space complexity is nothing but O of uh, we we didn't took any additional variable, we have just doubled this one, so yeah, we can say that O of n only, that because we have doubled this, right? So that is additional space that we are expanding the string to. So that is the space and time complexity for this approach. Okay, so at max it would be 2n. Now, same thing we will do, but we will do using C++ STL. Okay, so we will have the similar check. First, we will check if length is, same or not. Not, then we can return false, and then we can do this, rotation from, let's say, starting from 0, and um, yeah, sorry, here we don't need to do the rotation. Yeah, so we will have something like, new string. So I'll just write the code, and I'll at the same time I'll explain also. So this code would be, I mean, this will cover both of this thing. Instead of manually calculating it, we will be using C++ STL. So we will again check the same thing. If s dot size is not equal to goal dot size, then we can return false. Okay, and otherwise the string, we can take it as new string, that is the double string, that would be s then plus was. This is simple plain string, concatenation, nothing more. Now what we can do is, in string there is a find method in C++ STL. We can find a string inside a string if it exists or not. Okay, so if it exists, it returns the, index where, starting index where it exists, and if it doesn't exist, it returns the last, length of the string. So indexes would be how it would be: 0, 1 till n minus 1, right? These are the indexes. But if we see the length, right, so it is n, the string length, and this cannot be index, this is outside index, out of bound, or whatever you can say, right? So in case if it doesn't find that string, it returns this value n. Okay, so index the we what we can do is, if so here we can have a simple, check if our new string dot find. Okay, so in new string, which is double of this s, here we are finding our goal. Okay, so this will return us the size. Now what we will check is if this size is less than this new string dot length, right, dot size. Okay, if that is the case, if this is less, right, then we know that it would be something from 0 till n minus 1. Okay, and then in that case we can return true. Otherwise, this new string was, returning n, which means this goal doesn't exist in this new string. Then in that case we can return false. Okay, so yeah, that is the code for this problem. And here we are finding this, and instead, in above we were manually finding it. Okay, so let's discuss the time complexity for this approach. So time complexity, if we see, so this overall, finding the string, the would take, O of n time, so it is O of n. And space complexity, if we see, so it is O of n, because we are doubling this initial string and taking it, keeping this new string variable. So yeah, that is all for this problem. I hope you like this video, and I hope you enjoyed watching this, the three approaches that I told. Thank you for watching. I'll attach the code and the other details in the description below. Thank you.